My name is Matthijs. I'm talking tonight about deploying microservices done right. I gave this title a while ago, and now I've been investigating microservices the last couple of months, and it's been sort of a journey for me. Maybe this title is a bit pretentious, but it was merely to trigger you to come here, because maybe I'm not that big of an expert as I claim I am. But I would like to take you on this journey that I went on the last couple of months to investigate microservices and all the things I covered. And I hope that there's something in my presentation for every one of you. How many of you have an application you consider to be monolithic? Show of hands. That's interesting. So to the same people. How many of you want to cut it down a bit? A little bit. I think that's sort of the same amount of people there. Is there anyone that said no? Oh, yes to the first question and no to the second question? Do you want to comment on why?
Well, sometimes things get cut up wrong. Sometimes they get cut up too small. Right. Sometimes even rather small things can be monolithic.
Okay.
But cutting down a large application doesn't always mean that you can solve simple.
True. I'll cover that later.
Yes, of course, these group of people already cut down the things, or haven't even started on the journey. Already have microservices.
So of the same people that just raised their hands, how many of you already started to cut down on the... That's fewer.
Okay. Already finished here.
You're never finished. Nice.
Never finished.
So, well, often the problem is that the architecture of the application doesn't make them easy to deploy, and the thing I want to talk about partially today as well is how to deploy these microservices. So before I continue to talk about it, there might be some people that don't know what it is, and I use the words of Sam Newman, small autonomous services that work together modeled around a business domain. One of the things I did in my journey was to read his book and kind of watch a lot of his slides, because he had a lot of interesting things to say. And actually, I want to touch upon today a couple of the main principles that he talks about.
Is it possible for you to step a little bit to the right a little bit? Yeah, that's great. Thanks a lot.
So these are the principles that Newman talks about in his slides, but I want to focus basically on these four. And these two are the hide implementation details and deploy independently kind of merged together in my talk, so you'll see. Who knows who this guy is?
Not sure.
No?
It's a new one.
It's not Sam. Douglas McElroy. Does that name ring a bell to anyone? No? Okay. It was actually an early Unix pioneer.
I would say something in the 50s.
It was actually more...
It looks 70s. Like.
It is actually 70s, exactly. It was in the 70s. And he is the inventor of the pipe symbol in Unix.
Ooh, cool.
So he made it possible to build things in a component-based way. And if you don't know what the pipe symbol is, for example, you can have one command and you can pipe the result of that command into another command. So in this case, I'm listing a folder and I'm getting my own name out of there. Let's see if there's a file folder with my in there. And while going through my journey, I stumbled on a couple of quotes of this guy that really made me think about why microservices are so great, and why and I asked myself, why didn't someone come up with it before? And people did, of course, but let me show you some of his quotes. Make each program do one thing well. To do a new job, build afresh rather than complicate old programs by adding new features. Okay, that kind of sounds familiar, right? So maybe some people will recognize it as like the single responsibility principle. Like, hey, this is pretty smart. Another thing he said was, expect the output of every program to become the input to another as yet unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive input. So it's like, okay, make it simple. Keep it simple. Input can become output. Output can become input to another program. This is exactly what he meant with this pipe symbol. And the third one is design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. This is one of the other things that is actually, I would say, vitally important to microservices, the why I will come back to later. So the first subject I want to talk about is modeled around the business domain. So this is actually the definition of the single responsibility principle. Gather together the things that change for the same reason and separate the things that change for different reasons. And a lot of you probably learned this type of architecture in school or at work, the 3-tier architecture. And lots of businesses are built upon this architecture. You have your presentation layer, your business layer, data. So we're like, okay, we're pulling apart these responsibilities. This is like single responsibility, right? We have a presentation layer. It's a responsibility. But the problem is every time you have to touch something or you have to add a feature to this kind of architecture. To touch the presentation layer, you need to add something to the business layer, and maybe you need to change your database, so you have to have some data access. So you have to, if you split your organization in a way like this, then every time you introduce a new feature, everyone needs to be hustled up and be ready to introduce this feature. So instead of slicing things horizontally, like the 3-tier architecture, we should slice things vertically. So for example, invoicing product like this. If you have your product and your teams like this, then you can have teams that are completely autonomous in their handling. They can become experts on their own subject, and they can be autonomous in deploying this feature because they don't need someone from the team front and someone from the team back end. No, they can just say, okay, we have a team where everyone that we need to release this thing is there, and we can. Well, this idea was not per se introduced, but very well explained in the book of Domain-Driven Design, where Eric Evans is explaining how you best composite your architecture. And he explains how these different features basically in your company, like I just said, the invoicing system, for example, how they are bounded in a way, and he calls it bounded contexts. And of course you have, for example, a customer service in your system where everyone kind of needs to interact with them, and everyone has a different view on this customer. And well, if you want to know more about that, I would strongly advise you to read at least an abstract or something of this book. It's very, very valuable. Also in the book, very important that he describes is that when a service is modeled around a business domain, they are much more stable. They don't tend to change very often because your business process is, and certainly when your company becomes older, your business domain starts to stabilize, and the interactions between the services start to be more normalized. So you can more easily model them this way. Second thing I want to talk about is the hide implementation details. But while I was making these slides, I was kind of getting the idea that the theme should be more like how to not break other people's shit. So, because the things that I learned is, we often see an architecture like this, where you have an application that is reading from a database, and then once your company grows, and maybe when you tried out microservices because you thought, okay, this is a new trend, I need to investigate some time with this. You thought, okay, let's put some microservice next to it, and since I have a lot of information like that is interesting in my database, maybe customers or something, maybe this other microservice needs to read from it too, because it needs the customer object. This is a very bad idea, because try to change the schema of this database. It will be very difficult to do this and not break the second service. And the more and more services or even in your monolithic application, the more different parts of your application you let into the internals of your database, the more tightly coupled system you get. This is a very bad idea. So how should you do it? You should hide your database. So how does that work? Well, you talk basically to the other service and you ask him to get the information for you. But you might say, okay, but this will be slow, or no, I need this information. Like I want to be directly coupled to this database, or I don't know. But then you will have the problem of the too tightly coupled stuff. Or maybe you should think that if it so desperately needs this database, maybe you shouldn't have split it into services after all. Maybe they should be together actually. This is how your comment arises. Okay, maybe you shouldn't split in two small parts, because then you get a lot of communication between these two. That might be dangerous. Okay, maybe it actually needs his own information and it needs to have its own database, and maybe you need to extract it from the other one and make sure it's in a separate database, not to clutter up these services. Okay, you say, well, actually the same goes for the monolith. So there's too bad there was a box around it. But the box around basically says, okay, it doesn't have to be services. Maybe when you are still in the monolith area of your company, these two might be in the same application, but the same goes for that. So you might say, no, but I have one part of my application that reads from this table and the other part reads from this table. Oh yeah, are you not secretly like querying or joining them under the hood or somewhere? Maybe you should try to really put them in different databases and see what happens to your application next.
How do you secure the integrity of the database once you end up with putting things on different databases? Like a customer here, a customer there.
So with the two databases, I didn't mean to replicate the information, but for example, one service might want to have a part of the customer. For example, for the sales department, the customer looks very different than to the shipping department of a company. So the shipping department just wants to know the customer ID and which orders they have. They don't really, or maybe the address, of course, they need to ship it to something. But the sales department only is really interested in how much sales this person had and whatever. So even the customer can be in a completely different service than the sales or the shipping department, as long as the source of truth will be this customer service, and the other services have the data that they need in their own database.
Within those databases, there might be similar records like address. And so if you change it on one side, how do you ensure the integrity with the other customer?
I think you should try at least to keep your information in one place and have it to be the single source of truth. If you really have to replicate data to another service for fast response times, for example, still keep the first database at the source of truth, but let it be like eventually consistent in the other database. So make them synchronized, but still keep the customer service as the single source of truth. So even when you have a monolith, you can do the same thing. You can have multiple databases in the same monolith working on your application. And once you, it's too bad that you can't see the boxes, but once you have this situation in your monolith, it's way easier to split off a chunk. Even maybe you don't want it at first because these are too tightly coupled. Maybe you don't want to split them, but you only find out by having this situation and seeing how much communication goes between these two. And finally, if you really think it adds value, you can actually make them asynchronous and really pull them apart to another system. Another thing I learned is about the tolerant reader pattern. And the tolerant reader pattern says a reader should be able to ignore changes we don't care about. And I found XPath for the people that use XML, for example, and JSON path for people that use JSON. And basically, what it says is that, for example, you have a request like this, or a response like this, and you need to get out the payment method. I want to get out the payment method. Of course, you could, go in and say, okay, I want the payment and method. This is using a JSON path, and then you would get a response of ideal. But this is very, you're really assuming the structure of your response. If you would make it a bit more flexible, you could actually say, okay, I want the method, whatever layer it is in. So, for example, if I change my response to have multiple transactions, maybe because you have a layered payment, a stacked payment, because you are you're reading, trying to find the method this way, it doesn't matter in which layer it is, it will find it anyway. In this case, it will find multiple. But because in the first place you were already assuming to get an array back, your application won't break once you use this JSON path way. So you can and with XML you can do exactly the same thing. So don't assume anything about the response you're getting back, and be flexible in what you can read. So another thing to keep in mind is how to use technology agnostic APIs, to use RESTful or at least REST to hide your implementation, because I've seen some organizations that use very tight-knit communication, like RPC calls that need to know a lot about the implementation on the other services side, which makes it very brittle, because if the other service changes its implementation, you don't have a response to work with. And then the other thing I learned is actually that RESTful has multiple maturity levels, and until now I've been using a lot of the apparently level 2 RESTful maturity level. The level 1 is when you have resources in REST. Level 2 is when you use HTTP verbs, so when you use like get and post and delete. And level 3 is when you use hypermedia as the engine of application state. Well, I really needed an engine. Kind of a mouthful. So who knows what HATOS is? Yeah, but what does it do? What is it? So it's links, exactly. So when you have this RESTful resource, you can have links to other interesting related resources. So for example, when you have a payment, you can have, or you have an account, you have a balance, and you can link to itself. Okay, if you need to get the balance again, you can get it here. Maybe if you want to do a deposit, you can do it there, or withdraw, you can do it there. This is the verb you need to use. And well, then you say, okay, but what is so special about this? And why is it called state? Well, it's stateful because when you change the balance of the account to 0, you won't get the option to withdraw, which actually makes sense. So if you have in your application, you have some buttons that say, okay, withdraw or deposit, you can, by this, you can know it's not available. I won't show it, or I will gray it out, or I will disable. Very handy. So now, next time you can say to
Are you guys using this at Mollie?
actually, we kind of invented it ourselves before there was a name for it. So there is something related, but it's not as done as smartly as this, I would say. So, but it is definitely something that we are looking into for the next iteration, and for sure the internal APIs that we're using. Because of course, Mollie has an API that is years and years old, and we are really proud that we have been able to keep it very stable for all these years. Even though with all the developing business processes that we have, it's very difficult to not create any breaking changes to your clients. That's often also a very limiting factor. So we're really trying to find our way there. But internally, we can do what we want. So we can have all the new tricks. According to Sam Newman, the guy I talked before, this is the most important part of microservices. Actually, my colleague said at the beginning that Sam Newman changed his terminology to have this part of the microservice wording. So he says it's a microservice is something that can be deployed independently. And so, yeah.
You said you want to change to a more RESTful interface in upcoming years, I guess. But you have, what did you say, about 30,000 customers? Yeah, you can't just ask them to change the interface within, let's say, 6 months.
No, exactly.
How are you going to plan that?
I will talk about it in a minute. Actually, it's a good question. I told you in the beginning the two pillars I was going to talk about, the independent deployable and the hide implementation details, sort of were a mix in my presentation. I didn't really find a good way to put these in one category, so this is part of that subject. So it's actually what I said before. A loosely coupled service knows as little as it needs to about the services with which it collaborates. So you have to limit the number of different types of calls from one service to another. The problem if you split two services that weren't supposed to be split, because they're actually quite, there's a lot of cohesion between them, they're kind of the same, then you get a lot of communication between them. They say it become very chatty. And that is normally a smell that there's tight coupling between them, and maybe you should merge these two microservices back together, because it's using a lot of your system's resources, and it might even be a performance problem because you have a lot of communication between these two. So when you find yourself in developing a microservice that needs lots of endpoints to communicate with another service, you really have to ask yourself, okay, maybe these two need to be one. So a system should be cohesive in its capabilities. It should work together. It should serve the same goal, but it should not be should not attract only new functionality like the plague, like everything building on top of. And this is very dangerous, because often it's very easy when you have a certain system to just put something on it, because it kind of works the same way, and it's easy because I already have that object, that consumer object, so why not just put this on it? Like, these consumers, I have emails of them here. Okay, so I can build a notification system on top of that because I already have their emails. Nice. But wait, that's kind of not the point. So it goes two ways. Sometimes you want them to be together. Sometimes you need to think twice, and that's often you need to be an advocate in your company to say, oh wait, one step back. Is this the proper place to put this new functionality? And actually, one of the things McElroy said in the beginning was you have to be able to write something quickly and throw it out again. So I heard someone say a microservice should not be more than 200 lines of code. Wow, 200 lines of code. That is really tiny, you know. But then you kind of think of the McElroy guy writing the pipes and all, but LS, for example, LS, every Unix distribution has an own rewritten version of LS, and it does exactly the same thing, and it's like a couple hundred lines of code. So you can pipe it easily into something else. So I'm not saying it should be 200 lines of code, but think of that next time you want to make a new feature. Because you don't want your system to look like that, you know, like, oh, you have a building here, you put it there and there and there, and then it starts to become very brittle, because if you need to change something here, what happens with the house over there, you know? It's kind of dangerous. Okay, so what to do when you don't want to your other services or your consumers to force them to upgrade. You don't want to, when you want to deploy separately, you want to not be in a lockstep with other services. You don't want to say, okay, I'm upgrading this service, so shit, on this is a dependency, I need to upgrade that as well because on this one, okay, and if I upgrade this one, you know, because then you lose all the benefits of having a microservice system. The whole thing is that your microservices can be deployed independently, so that every team can be autonomous. They can just build their stuff, build a new feature, ship it, build a new feature, ship it. And what if you introduce a breaking change? Okay, so introduce a new endpoint. Say, okay, we're not forcing you to upgrade, but you know, if you want to get on the new stuff, you have to get on version 2. And of course, you cannot introduce stuff like that every couple of months, because your consumers, especially your clients, will never be able to continue with that. But internally, when you have microservices, you can tell your colleagues, okay, man, there's some nice new features in this customer service, but you need the new version. And you give them time to migrate, because at some point you cannot have a version 1, 2, 3, 4, 5 next to each other, because that will give a lot of overhead in your service, of course. So ideally, you want to only support one version before the last one, give people some time to upgrade, and then clean up the old code. Another thing I learned, which I thought was really cool, is consumer-driven contracts. And actually, I read that they sort of set it against end-to-end tests. Who's using end-to-end tests in the what kind of technology are you using in this? Nothing specific? Selenium. Okay. It's super fast, right?
It's better than stuff breaking.
It's better than stuff breaking, but you don't want your pipelines to take like hours and hours and having it run every time, because you want to iterate quickly. You want to build a new feature, ship it, and have it live within ideally minutes, not hours. So what is the proposition? Consumer-driven contracts is creating an expectation of what you expect from the other microservice, making it explicit, and sharing it between the microservices, saying, hey, you know what, customer services, I'm this service, I expect you to give me this response. If you don't give it, I will break. So Pact is something created that facilitates exactly that. And the way it works is that in your application, you start by defining expectations using Pact DSL. It's a special language, and then you launch your mock server to run it and to generate this Pact JSON file. I mean, you can do it yourself, but it's more work if you do it completely yourself. Then this producing side basically gets it, either from like a central repository or from Pact Broker. I will tell something more about that. And it can verify if the expectations that the consumer service has are being met, and then we can continue to roll out the service. So if this one is trying to upgrade, you can just say, okay, which services are integrating my service? Okay, and what are their expectations? Okay, let's check it. Okay, well, everything seems to still work fine. Okay, I can release, no problem. But they need to access this thing. So I've seen people committing the one service's expectations directly to the other one, but Pact Broker is something that another organization made that allows to share these packs between projects. And it makes it really nice. You don't have to create an end-to-end test for every integration you have. You don't have to walk every code path or introduce feature in your application, which takes a lot of time. And if you try to do like end-to-end types of end-to-end tests, then you will get a lot of tests every time you introduce a new service. Pact Broker also lets you visualize the relationships. You don't see it, but there's actually lines between all your services, so you can see exactly which one is depending on which one. And it can generate documentation for you, which is really nice.
Is Pact like you have to use a specific language, or is it language agnostic?
It's agnostic. So there's libraries for, I don't know, Java, JavaScript, a whole bunch of them. You can I will share the slides, and there's links to the Pact Foundation and Pact Broker and all the things in there.
Where do you manage your dependencies?
So I've been thinking about this because we know about semantic versioning. I will talk a bit about that as well. So maybe every time you release this kind of thing, you should let the other services know that there's new features available, not breaking breaking changes, because then you will introduce an endpoint. But I think it would be smart to have some kind of dependency manager to show where you are microservices, which ones you are using. But I haven't dived that deep yet. I haven't found one, or I haven't really searched for one. But there must be something.
Yeah, you must be in need of some kind of release orchestration.
That sounds like a good plan, exactly. But I haven't read on it yet, so I would be really. If someone else knows something for that, release. No? Okay, I would be really interested to hear something about it.
But doesn't the image you're showing here, doesn't that show dependencies?
It shows dependencies, but it would be very nice to have in a specific service to know exactly, without having to open this kind of thing, to know exactly which things it's depending upon, and then you know much easier if you can integrate with a newer version, for example, if it's released of a microservice that you're depending on. So yeah. The last thing I want to talk about is culture of automation, and this is actually what I wanted to talk about initially, but there was so much more to tell you guys, and there was like the introduction became bigger than the ending. But the culture of automation is really important with having lots of microservices, because the more things you have to deploy, the more things you have to manage. So at some point you can have like a couple of terminals open and be like, okay, this one is running fine, this one is running fine, but after you have your 20th or something microservice, you're gonna lose track. So it's really important to automate stuff. Because microservices, they add also a lot of complexity, so you have to keep in mind there's lots of moving parts you need to take track of. So there's infrastructure automation, which is important, but I'm not gonna touch a lot about that now. Automated testing, which all of you are doing, of course, and continuous delivery. And important in the automation is, of course, the build pipelines. At Mollie, we are right now using Bitbucket pipelines to do the continuous integration, and struggling a bit with them. It has its ups and downs. Performance and.
Wasn't that used to call Dabroek?
No,
it was a separate product,
Yeah.
but they now implemented it into Bitbucket, the repos.
Okay.
So you are building Docker images, or what are you building?
Yeah, well, it depends on the project. We have several projects, and some of them we are building Docker images. Some of them we are building JavaScript packages or.
But we're not building any Docker images inside the pipeline. It is possible, but it only became possible after we implemented it in a working situation. And
We're just actually doing it in our
Yeah.
this kind of pipeline.
And at the moment we're also looking into several other products to facilitate our continuous integration, like CodeShip, for example, and there's several other.
Yeah, I do it like Circus CI, Travis CI, Jenkins, CodeShip.
Yeah.
There's lots of them. But the thing I learned was that once you build something, create an artifact, that you should use the same artifact when you go through the pipeline. So you should always use the same thing, the same piece of code to test, and not rebuild it every time you go into a new phase. And it kind of makes sense because maybe in a new phase or a new environment you introduce a change or a difference between the previous one, so you cannot be sure.
What are you using as a pipeline orchestrator?
Honestly, Jill?
At the moment it's integrated into Bitbucket. So it's all in one solution, but all those pipelines can be triggered by push or
Something like Jenkins or.
No, we don't use Jenkins.
But it's sort of the same thing.
Yeah, Jenkins is similar like pipelines from Bitbucket. Only when you use Bitbucket's repo for Git, you can also use their pipelines, and it's already integrated into itself.
Okay.
So you eliminate the need for.
So is this something to do with Bamboo or?
No, Bamboo is the old product, and they recently brought it to their cloud Git repos, and it's now Bitbucket pipelines. So it's I think it's still the free trials and stuff, but they're also paid accounts.
But you only get it hosted. You only get it in the cloud hosted.
As far as I know, it is. And if you want to have it on your custom servers, then you might need Bamboo, but they're phasing it out.
I found out what the thing is that you're all really interested in. This is the part, the pipelines part.
In the pipeline, you also have to have the user acceptance. Are they automated or manual?
I think they can be both, right?
Yeah, they can, but in your case.
In our case, it's manual. Because I personally, I don't really like to rely on all the automated interaction stuff that you have to build, the end-to-end test kind of thing that automates the headless browser clicking through stuff. I'm not a big fan myself.
Manually introduces
of course, it should be.
a slowdown in the delivery.
That's why you have Pact actually. So of course you have the actually what we are introducing right now, or what we are looking into, is because the end-to-end tests are more of checking if the user interface is still correct and if it's still working, because the end-to-end test makes sure that the business layer is functioning correctly, and so the functionality should be there. Then you can of course have an end-to-end test to click through your interface to see if to confirm everything is working. But most of the time when we do that, we figure out it's something in the user interface that is off. There's a margin too much there or whatever, and that's kind of stuff that doesn't have to be found out in this end-to-end test. You can actually, we are using just snapshots. So we have React components, and we are using snapshots to see how they are and if they didn't change. But actually you have the same thing with image snapshots. So you can use just image snapshots to take an image of your interface. It will save it into a PNG file or something in your Git repository, and the next time it will just run in the background again and see if your padding and margins are still the same. And it actually will give you a visual diff of how your interface changed when it changes. Didn't put it in my slides, but you should definitely check that out. Just image snapshots. Yeah, I was talking about immutability basically in your pipelines. So to make sure that your artifacts are the same once they move through the pipelines. And I promised my friend Floris on the first line that I would talk a little bit about Docker and at least show the logo. So there it is. Yeah. Just to be hip and I don't know. So immutable images and immutable service. Also, we are using Kubernetes now for some of our services, and it's really nice to have these stateless servers running that you can just shoot, and then it will just fire up a new one, and no problem at all. So it's very important that with your deployments you can automate this stuff so that you just don't have to spend any time on maintaining and looking at that, and of course you should monitor, but
which cloud provider are you using?
Sorry?
Which cloud provider are you using?
Google Container Engine thing is, yes.
Yeah.
So, but also actually in the regular day-to-day development, and I'm personally I like to do a lot of JavaScript, but we're also doing things in PHP. But I noticed that we're doing a lot of, I don't know, repeatable steps here, like okay, you're developing, committing, then you push and you publish, you have to tag stuff, and certainly when you're using semantic versioning, you have to take care that you have the right semantic version. You have to think about, okay, what did I introduce? I have to have one feature and it's one there, and I have a fix, there should be one there. And then you have to tag it, you have to write a bit in the changelog so that the other developers, they know what changed. And also, I mean, mostly for our external clients, but also internally, your colleagues need to know what changed in this service. And certainly when you have all these different microservices and you have this file that says, okay, I have this version, you want to know, okay, is it worth it to upgrade? So I would like to automate this too. And there's actually a package called semantic release. Who heard about semantic release? Okay, no, really? Cool. So for the JavaScript part, the semantic release, it basically looks at your commit messages. You have to take a style of commit messages basically, and you can use commitism, which is a command line or a CLI tool that helps you to automate it. You can basically type, for example, make commit, and then you get this interface where you can choose if it was a feature or a fix or whatever, break and change. And you can type the scope of your change, and you can type a commit message. And because they are standardized, it can actually just at the end, once you release your software, you can just say make release. It will look at these commit messages and say, okay, you introduced so many breaking changes, you introduced so many fixes, so you should be on this version, and you should, I don't know, introduce a new version, like major version, because you introduced a breaking change, which is really handy. You don't have to take care of that anymore. You don't have to worry about that anymore. So check that out. Oh, actually, I have a picture of that interface. So you basically can scroll through that, saying, okay, it's a refactor, it's a test, it's just a chore that I needed to do. It's just a styling issue or whatever. Easy to also group them together. See exactly in your changelog, automated changelog, what changed. So, automating releases with confidence. What can you do? The things I said, deploy the same way everywhere. Actually, we had like JavaScript and PHP and stuff, and everyone was using Yarn, and then there's NPM and this kind of stuff, and the Composer, and we just wanted to standardize it for everyone that opens up a project. You know what you have to do. You can do make, deploy, or make whatever. It's all the same. That's really nice. Use your build pipelines. Use the contract-driven test with, for example, Pact. Coexist multiple endpoints to be able to iterate fast and to just continue developing, giving your teams the ownership of their products, and use semantic versioning. So these were the topics I talked about, and I would say try to automate everything and kill all humans. Any more questions?
Can you detail more about the semantic versioning of microservices? Exactly what you mean?
So semantic versioning is I'm not sure how what you know about semantic versioning.
Well, the term itself, I don't know exactly what it means, but
okay, so
I probably can deduce an idea.
Yeah, so there's this number with a first number dot second number third number. The third number indicates when there has been a fix, some minor thing changed to fix a problem like a bug or something, but did not break in any way the code. The second number explains that there has been a feature introduced, a new feature that could be interesting for you. And the first number is the major or the breaking change. If that updates, you know for sure that a breaking change was introduced. So your software might not work anymore once you upgrade. So basically this number, this version that you're on, signifies exactly which features you have and how big of a trouble an upgrade might be.
Okay, but how then you relate that with what you mentioned about the endpoints of several versions of the microservices?
Right.
Because then, well, I don't know if you tagged it on the development, then you know that a major version was introduced and some breaking changes were also introduced.
Right.
But how do you relate that with the versioning of endpoints of the microservices for your clients?
So there's
Are they directly related, or?
I think that would be a good idea. I think you can play with that yourself, and it depends on how you want to do that. For us, it doesn't matter. We have like externally we have one version. We make sure it works for everyone. We don't introduce breaking changes. But you can go as granular as you want yourself. For me, I would say the endpoint is the only thing that's really important to know is does it break or not. So for me, the major version is the most important. You have a version 1 and version 2, like the two ones next to each other. Once it really breaks, you introduce a second version and you tell everyone to upgrade. But of course, if you want to go more granular and say, okay, I created another feature, this is another endpoint, or give me a header with the right the version that you want. I don't know, it's up to you, I guess.
You said you won't change the interface to your customers? Is that what you said just? Or
No, of course there are changes in our API, our customer-facing API, but they're not breaking changes. So we keep support for what we had before. Of course we introduce new features, but we do it without breaking.
Okay, thank you.
Yeah. Cool. Questions?
Then let's
Yeah. Okay.